Hey everyone, let's just dive right in. We spend so much of our daily lives completely fixated on the here and now. We worry about deadlines, that crazy 24/7 news cycle, what we're doing this weekend. But today we're doing an explainer that takes an awe-inspiring, frankly mind-bending journey through Earth's deep time. We're going to map out the entire life cycle of our planet, literally all the way to its absolute end, using some absolutely fascinating geological and astronomical timelines.
It really is a profound question. What actually happens when we zoom out from our immediate day-to-day anxieties and look at the ultimate cosmic fate of our planet? When we step back and look at the massive, unimaginable scale of where Earth is heading, the big picture is just completely breathtaking. But to understand the end, we kind of have to start exactly where we are right now. Section 1. The Human Era. 0 to 300 years. Right now, we're sitting in the middle of a massive global crisis, the sixth mass extinction. And if you think about the math for a second, it's pretty crazy. In just the last 300 years, human beings have altered the surface of the planet more than all of Earth's rivers combined have done in that exact same time frame. Think about that. We are this sudden, massive geological force, fundamentally shifting ecosystems at just blinding speed. And that brings us to what experts are calling the 2100 test. Basically, the next 75 years are, without a doubt, the most consequential in human history. It's a make-or-break moment. Depending on whether we can rapidly decarbonize, Earth will either stabilize, or we're looking at civilizational collapse as the tropics become lethally hot. It's absolutely crucial. So obviously, our immediate survival is hanging in the balance here. But that naturally begs a rather provocative question, doesn't it? What happens if we fail? What actually happens to this magnificent blue marble if humanity just vanishes? Section 2. The Earth Reset. 10 to 1 million years. Once we're removed from the equation, the planet doesn't mourn us, it just gets right back to work. Think about the stark contrast between human time and geologic time. In literally just 10 years, untamed nature actively reclaims our major cities. Give it 100 years, and deep forests completely return. It's like we were never there. But on the geologic side, the Earth is preparing for some massive, massive shifts. Because regardless of what humans did or didn't do, the ice ages are coming back. In about 50,000 to 100,000 years, the landmarks we know and love will be totally buried. Imagine the skylines of New York and London entirely crushed under a full kilometer of solid ice. A kilometer! And within a million years, a supervolcano eruption, think Yellowstone or Toba, is an absolute statistical certainty. And that will trigger a massive, decade-long volcanic winter. Section 3. Geological reshaping. 10 million to 250 million years. Okay, so now we're moving past surface changes and looking at the epic, slow-motion shifting of the Earth's actual crust. Right now, as we speak, the continent of Africa is tearing apart. In 10 million years, a brand new ocean will form right where the East African Rift is today. But fast forward 250 million years, and the continents actually reverse course and just slam back together. And that collision forms what geologists call Pangea Proxima. Some people call it Amasia. Basically, all of our distinct continents are going to merge into one giant, unified landmass. And because it's so incredibly vast, moisture from the ocean just won't be able to reach the center. That means the heart of the planet is going to turn into this impossibly harsh, arid, and just totally lifeless interior desert. Section 4. Biological end. 600 million years. Now we're zooming way out, transitioning away from just geological shifts to confront the ultimate endpoint of life itself. And the main driver of this end is a relentless cosmic ticking clock. Get this, our sun gets 1% brighter and hotter every 100 million years. For a long time, Earth can absorb this, but right at the 600 million year mark, we cross a fatal threshold. And here's how that actually plays out. It's a highly counterintuitive domino effect. As the sun's heat drastically warms the planet, chemical weathering accelerates, right? This forces the Earth's rocks to absorb carbon dioxide way faster than volcanoes can replace it, so CO2 levels plummet. They go so low that photosynthesis becomes literally impossible. All plant life dies. And without plants, the entire global food chain collapses in an instant. Earth, which was once teeming with diverse animals, reverts entirely back into a microbial world. Section 5. The boiling oceans. 1 billion years. Okay, things escalate really dramatically here. The sun is now a full 10% brighter, and that triggers what's called a moist greenhouse feedback loop. The heat causes our oceans to literally evaporate into the atmosphere. Then, intense UV radiation breaks apart those water molecules, and the lighter hydrogen just escapes into space forever. Poof, gone. Earth loses its water entirely, and it starts looking completely alien, actually a lot like Venus does today.
Section 6. The sun's final act. 5 billion to 7.59 billion years. It's honestly hard to wrap your head around timeframes this vast, isn't it? At 5 billion years, our sun finally runs out of its hydrogen fuel and swells up into a massive red giant. By 7.5 billion years, its expanding surface will literally swallow Mercury and Venus whole. And then, well, it turns its sights on us. 7.59 billion years from now. This staggering number is the definitive estimated year of Earth's absolute demise. At this exact point in the deep future, our dried-out, barren rock of a planet will either be completely scorched into molten slag, or its orbit will degrade, causing it to spiral directly into the sun's fiery atmosphere, where it'll be totally vaporized, just gone. But wait, the story doesn't actually end with destruction. It ends with this really beautiful kind of cosmic recycling. After consuming Earth, the sun will shed its outer layers and shrink down into a tiny glowing white dwarf, before eventually cooling, over trillions of years, into a cold black dwarf in the dark expanse of space. But what about Earth? Well, the scattered vaporized atoms of our planet will drift out, eventually joining a new stellar cloud.
The atoms that once made up our oceans, our deep forests, our bustling cities, and yeah, even us, they'll be scattered into the galaxy. They will eventually become stardust once again. Maybe, just maybe, one day coalescing to form a brand new planet, orbiting a brand new star. It's a profoundly poetic return to the cosmos, don't you think? Which brings us right back to where we are today. Seeing that we are ultimately destined to return to the stars, does knowing our stardust fate change how you view our vital next 75 years? For me, it reminds us that while the Earth's ultimate timeline is totally out of our hands, the human era, well, that's entirely up to us. Thank you so much for joining me on this explainer through deep time. Keep questioning, keep learning, and I'll catch you next time.